Yes, so let's continue. I have taken here one aromatic tertiary amine. So its name, as we have done earlier, it is now same groups are present, so I'll write it NN dimethyl. If I write aniline, then it will be the common name, fine. And in IUPAC, it will be written as NN dimethyl benzenamine, fine. So like that you can name the aromatic compound. The most important aromatic amine which we will study in this chapter will be aniline, right? So you should be knowing aniline nitrogen is directly linked to the benzene ring and aniline is a primary amine, fine. Okay, now let's further discuss some more naming of aromatic amines, in which we will substitute aniline further. Suppose I have substitution by CS3 group. The common name for this compound is toluidine, fine. Or in IUPAC, it is NH2. NH2 and NH3, these groups are present at ortho position, so it is orthotoluidine, fine. Otherwise, IUPAC name will be, it is at 1, this is position 2, so it is 2-methyl benzenamine, or you can also write here 2-methyl aniline is also taken as the IUPAC name, fine. Similarly, if it is present at say meta position, so it will be again meta toluidine, or the name will remain same, only the position. Now this time here it will be 1, 2, 3, 3-methyl methyl benzenamine or 3-methyl aniline, right? Similarly, we can also have this group at para position, so it is common name is para toluidine, right? And among IUPAC name you will be having here like the position is 1, 2, 3, 4, 4-methyl aniline or 4-methyl benzenamine, fine. So this is one. Then from examination point of view, one naming is usually asked. It is when it is substituted by methoxy group, fine. So the common name for this compound we have taken, it is at position ortho, it is ortho anisidine is the common name, while IUPAC name is usually asked in exam. It is, you can simply write it 2-methoxy aniline, or you can write I have written it. It is 2-methoxy aniline or 2-methoxy benzenamine, fine. Similarly, if you keep on changing its position, if it is at this position, then it will be meta-anisidine. If it is at para position, para-anisidine, right? Similarly, you can also change it as 2, then 3-methoxyaniline, then 4-methoxyaniline. Like that you can easily name it, fine. So I think this much is sufficient for IUPAC naming of different classes of amines, right? Now I will take up the next very important, that is isomerism in amines, fine. So in amines we have different type of I will discuss here only structural isomerism, fine. So number one, we have here chain isomerism. So you all know chain isomerism, where the length of the chain will be different, but the functional group, everything will remain same, right? So for example here CH3, CH, CH3, CH2, NH2, fine. So you see here, this is 1, 2, 3 and 4, this is 1, 2 and 3, So as a branch is there, so length of the chain is reduced. These two are chain isomers. If you will see, their molecular formulas will be same, but the length of the chain is different. Moreover, the position of NH2 group is again same. So it's not a position isomer. Fine. So this is one example. Then number two, they have a very simple position isomerism. In position isomerism, it will be changes in the position of the functional group NH2. So here it is 1, 2, 3 and 4. But if I write this compound like this, so here I have already taken its IUPAC name. Numbering starts from 1, 2, 3, 4. NH2 group is present at position 2. Fine. So remember, it's not a chain isomer, though it appears to the student that this is some branch is there and chain is only of 3 carbon, but no. I have already told you, you have to start the chain from here. 1, 2, 3. All carbon are in continuity. Fine. So position of NH2 is changed, so it is position isomerism. Then number 3, we have a special isomerism. In this case is metamerism. In metamerism, we know in metamerism the alkyl groups present on the either side of the functional group have changes. Now, for example, I have a secondary amine. This is a secondary amine, you know. One side we have propyl group, one side we have methyl group, right? Now, if I write its isomer, if I just write the structure like this, now you see there are 4 carbon here, there are 2 plus 2, 4 carbon here, but the groups are changed. Here you have ethyl and ethyl on either side. Fine. So this is an example of metamerism where functional group on the either side of functional group, such type of isomerism is also exist in ketones, in ethers, where you have functional group, where you have alkyl groups on the either side of the functional group, right? So in secondary amine we have this. Moreover, in tertiary amine we can also have, if you have a compound like this, fine, it is tertiary amine. So in tertiary amine, if I write its isomer, I can write it like this. Some groups are changed here. Fine. So you see, now the different groups are present here. Propyl, methyl and ethyl are present, but here only ethyl, ethyl and ethyl are present. So like that, this functional group is there. Now lastly, I have fourth is functional isomerism. In functional isomerism, it's very simple. Primary, secondary and tertiary amines have a relation of functional isomerism if their molecular formulas are same. For example, CH3, CH2, CH2, CH2